This is an AQA GCSE Combined Science Trilogy paper, Higher Tier Chemistry Paper 1H from June 21. This question is about the periodic table. Figure 1 shows part of Mendeleev's version of the periodic table. Which group of elements had not been discovered when Mendeleev's version of the periodic table was published? You might know this off by heart, otherwise just have a look at what's missing. We're actually missing the noble gases, group 0. Either of those answers is appropriate here. Figure 2 represents different models of the atom. Which model represents the plum pudding model? So the plum pudding model had the sponge, which was made up of positive charge, embedded with plums, which were supposed to be negative. So it looked like this. So which of these models matches up here? It is B. Which model resulted from Chadwick's experimental work? Chadwick was the guy that discovered neutrons. So let's have a look at the one with neutrons in it. We can see them over here, embedded with the protons, so it's A. Potassium has different isotopes. What is meant by isotopes? You should refer to subatomic particles. So that means we need to talk about protons and neutrons in our answer. So let's define it. Atoms of the same element with the same number of protons. Remember, they must have the same number of protons to be the same element, but a different number of neutrons. So other definitions of isotopes, we'll talk about them having the same atomic number but different mass number, but it's the fact that they wanted us to refer to subatomic particles, which is why I mentioned both protons and neutrons here. Table 1 shows the mass numbers and the percentage abundances of 2 isotopes of potassium. Calculate the relative atomic mass of potassium. Give your answer to 1 decimal place. So how we go about answering this is we take the mass number of the first isotope and multiply it by its percentage abundance. Add it to the mass number of the second isotope. Multiply that by its abundance, and then we divide by 100. So what does that look like? Well, it's 39 times 93.1 plus 41 times 6.9 divided by 100 to get an answer of 39.138. But we need our answer. Don't forget to check to 1 decimal place, so that's 39.1. Acids react to produce salts. Universal indicator is added to water and then nitric acid is added to the mixture. Give the colour change when nitric acid is added to the mixture of universal indicator and water. So you're going from a green neutral pH with that water, and then if you add an acid, it's going to go red. So green to red. So this one here, indicating a low pH. What happens to the pH of water when nitric acid is added? Yep, I said a low pH, so that pH must have decreased. What is the state symbol for nitric acid? You might have seen it like this before. It is an aqueous solution, AQ. Zinc carbonate reacts with nitric acid. The word equation for the reaction is: give 2 observations that would be made when zinc carbonate is added to nitric acid until the zinc carbonate is in excess. First of all, you'd see fizzing or effervescence, which is the release of carbon dioxide, which we can see over here. And then that white solid, that zinc carbonate, would disappear as it reacts away. The formula of the zinc ion is Zn2+. The formula of the nitrate ion is NO3-. What is the formula of zinc nitrate? Several ways to do this. We can start by looking at our ion charges and working out that they're not balanced. We have effectively too much zinc, so how do we balance that? By adding a second nitrate ion. So fundamentally you end up with this. You need a bracket because that 2 applies to everything inside the bracket. Equally, you could have taken your 2 ions and done the swap and drop method, which means bringing that 2 down here, that invisible 1 down there, because look, you end up at the same result. So that's the answer. Acids react with soluble metal oxides to produce salts. Plan a method to produce a pure dry sample of the soluble salt copper chloride from an acid and a metal oxide. It's worth 6 marks, so we need to go through this method in a lot of detail to work out how we're going to get our dry sample of salt from these 2 reactants. So the first thing we need to do is react the hydrochloric acid with copper oxide. Let's use a suitable container, such as a beaker. You could warm it to make that happen faster. We need to add the solid copper oxide until it's in excess and stir the solution. Because we have that unreacted copper oxide solid left, you want to filter that off and pour the remaining solution into an evaporating basin. Heat gently. Why do we need to do that? To evaporate some of the water. After all, we want a hydrated crystal here. And then finally, we need to let them cool and dry, and give a method for doing this, so potentially on filter paper. So to go over this method again, we've taken our acid and our metal oxide, we've stirred them together inside a beaker, we've added the metal oxide in excess, and that means we therefore need to filter to get the remaining salt solution. Because we've been asked to find a dry sample, it means we need to heat it to evaporate some of the water, and then finally leave to cool and dry on filter paper. This question is about energy change. A student investigated the temperature change when 10 grams of ammonium nitrate was added to 100 centimetres cubed of water. This is the method used. Measure the temperature of 100 centimetres cubed of water. Add 10 grams of ammonium nitrate. Stir once. Measure the temperature of the solution every minute for 7 minutes. What is the dependent variable in this investigation? So dependent variable is what you're measuring. So check the method for measuring the temperature of the solution. Give 3 improvements to the investigation to make the results more accurate. Okay, because we're measuring the change in temperature, we're going to have huge heat losses because of the fact that we are using a glass beaker. So let's use a more insulating material such as a polystyrene cup. We could add a lid to stop the heat escaping there. We definitely want to stir the ammonium nitrate with the water in order to first of all get that reaction and get a more even temperature throughout. And then it's always good to say repeat and calculate a mean. You could even change the thermometer, change it to a digital thermometer. Figure 4 shows the results. Explain the results. Let's have a look then. So we can see from 0 to 1.5 minutes, the temperature is decreasing. Why is that? Well, in an endothermic reaction, remember, it gets colder. So that's what's taking place here when the ammonium nitrate reacts. And then after 1.5 minutes, we can see that there's a gradual temperature increase. Why? Because energy is being transferred to the solution from the surroundings. Draw a reaction profile for an exothermic reaction. Remember, that's when the energy change is negative. You should label the energy level of the reactants and products, the activation energy, and the overall energy change. So because that overall energy change is negative, it means that our reactants must sit higher, at a higher energy level than the products. Then remember, the activation energy is the minimum amount of energy required for a reaction to occur. So you must take that line from the reactants to the top of that peak. And that is your activation energy. And then lastly, your overall energy change is just the difference in energy from your reactants to your products. Make sure those arrows fully meet and just check you've done all these things. And there's that whole delta H negative thing. Look, the products sit beneath the reactants. Carbon can exist in a number of different structures. The first fullerene to be discovered was Buckminster fullerene. What is the formula of Buckminster fullerene? It's actually C60, so we're looking for that option there. Graphite is a form of carbon. Explain why graphite conducts electricity. Why? Because graphite has delocalized electrons, and what does that mean? Which are free to move and carry electrical charge through the structure. Steel is an alloy of carbon and iron. Explain why steel is harder than iron. It's the same question. So, why are alloys harder? Because the carbon atoms have different sizes compared to the iron atoms. And what does this do? It distorts the structure of the steel, meaning that the layers of ions can't slide over each other as easily. Iron is alloyed with carbon and other metals to make stainless steel. A stainless steel fork contains 71.92% iron. Table 2 shows the mass of each element in the fork. Calculate the mass iron X in the fork. Let's first of all add up all of these. So that's 16.29 grams, and that accounts for, let's do 100 minus 71.92. So that accounts for 28.08%. So to find the mass of the fork, its total mass, we take the individual masses of those other elements and divide it by their percentage, times it by 100. So we know that the total mass of the fork is 58.01 grams. Then it's a matter of taking the mass of the other elements away from that to find the mass of iron, which is 41.72. This question is about the electrolysis of aqueous solutions. Hydrogen gas and chlorine gas are produced when sodium chloride solution is electrolyzed. Hydrogen ions are attracted to the negative electrode. The half equation for this reaction is this. What type of reaction happens at the negative electrode? Give a reason for your answer. So they're asking basically, is it oxidation or reduction? Remember, oil rig tells you that oxidation is loss of electrons, whereas reduction is gain of electrons. So what's happening here, we're getting electrons gained, which means it's reduction, and just point out why. Chloride ions are attracted to the positive electrode. Complete the half equation for the production of chlorine gas. So they've been nice here, they've told you what the formula of chlorine gas is, so let's pop it there, get it balanced. And then how do we go from having a 2 negative charge over here to something which is neutral? Well, we take away 2 electrons, which we show by adding them to the right-hand side. So this is oxidation. Hydrogen gas and oxygen gas are produced when sodium sulfate solution is electrolyzed. Explain how oxygen gas is produced in the electrolysis of sodium sulfate solution. So this is your sodium sulfate solution. And because it's an aqueous solution, it means it contains water molecules which break down to produce the hydroxide ions. So we'll start by writing that. And because it is electrolysis, because they're negatively charged, they'll be attracted to the anode, the positive electrode. And what happens there is those hydroxide ions are oxidized, i.e. they lose electrons to produce oxygen gas. Metal oxides are produced when metals are heated in air. A student investigated the change in mass when 0.12 grams of magnesium was heated in air. The student measured the mass of magnesium oxide produced. 0.12 grams of magnesium reacted to produce 0.2 grams of magnesium oxide. Calculate the number of moles of oxygen that reacted. So if we find the difference between these two numbers, it will tell us how much oxygen got added to that magnesium. 0.08 grams. And then to find the number of moles, we use this formula triangle, which states that number of moles is mass divided by mR. And then we need to find out the mR of oxygen, so that's O2. Be careful with that 2, so it's 16 times 2. Put that into your calculator to get 0.0025. The student repeated the experiment without a lid on the crucible. Suggest why the mass of magnesium oxide produced would be different without a lid on the crucible. Because if you didn't have a lid on the crucible, the mass of magnesium oxide would be less. And why is that? because some of that magnesium oxide might have escaped. Copper reacts with oxygen to produce copper oxide. 63.5 grams of copper produces 79.5 grams of copper oxide. Calculate the mass of copper oxide produced when 0.5 grams of copper reacts with oxygen. Give your answer to 3 sig fig. So let's start with a balanced equation. I always like to use a table for my mole calculations. Let's get ourselves set up with this formula triangle. So we know we have 0.5 grams of copper. We're being asked to find the mass of copper oxide. Let's start by filling in our MRs. So use your periodic table to find the relative atomic mass of copper. It is 64. What about that of copper oxide? It's 80. We can now find out the number of moles of copper by doing mass divided by MR, so that's 0.5 divided by 64. Don't round these numbers, keep them long. Check the mole connection. It's the same, so we're allowed to write that over here. And then lastly, just to find that mass, remember we do MR times number of moles, so just multiply these two numbers together to get 0.625 as your answer, and that's 3 sig fig. Iron reacts with oxygen to produce an oxide of iron. 0.015 moles of iron reacts with 0.01 moles of oxygen gas. Determine the formula of iron oxide produced and the balance symbol equation. So this is effectively an empirical formulae question. So we list the elements we're interested in, and we need the number of moles of each. So we've been told we have 0.015 moles of iron, but how many moles of oxygen do we have? Wow, we have 0.01 moles of O2. So how many oxygen atoms is that the equivalent of? Be careful here, it's double. Then we need a ratio. So to do that, we divide by the smallest number. So divide both sides by 0.015 to get a ratio of 1 to 1.3 recurring. And then because it's a ratio, we need to have this in terms of whole numbers. Multiply both of these numbers by 3 to get a ratio of 3 to 4. And so actually our formula of iron oxide is Fe3O4. And then we want the balance symbol equation. So we've got iron reacting with oxygen, which we've been given the formula of. We know it makes Fe3O4. Now let's balance it. Let's start with our ions. So we have 3 ions on the right hand side. Now we've got 3 on the left, but what about our oxygens? Well, we have 4 on the right hand side. So we need to put a large 2 there to get that balanced. Methane, ethane, propane and butane all react with oxygen to produce carbon dioxide and water. Suggest why a mixture of methane and oxygen does not react at room temperature. Answer in terms of particles. Okay, what's true about low temperature? Well, the particles are colliding in this case, but with kinetic energy which is too low, which means that they have insufficient energy to overcome the activation energy. Because remember, activation energy is the minimum amount of energy required for a reaction to occur. Table 3 shows the energy released when methane, ethane and propane react with oxygen to form carbon dioxide and water. Predict the energy released when butane, C4H10, reacts with oxygen to produce carbon dioxide and water. So butane has 4 carbon atoms. So if we look at this trend, it increases the energy released. Let's work out the difference between these numbers. So that's 480. Yeah, that's also 480. So we need to add 480 to 1640 to get our value for butane. Propane reacts with oxygen to produce carbon dioxide and water. The displayed formula equation for the reaction is this. The reaction is exothermic. In the reaction, the energy released when forming new bonds is 1,640 kilojoules per mole, greater than the energy needed when breaking bonds. Calculate the C single bond C bond energy. So let's first of all calculate our bonds broken. So we're looking over here. Count the number of CH bonds. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 times 410. Then we have 2 lots of the C single bond C, which we're after, which is X. And then we need 5 lots of the O double bond O. Let's add that up. So that becomes 5,780 plus 2x. What about bonds formed? So we're looking at the right hand side of the equation. We have 6 lots of O double bond C bonds. And then 8 lots of OH bonds. Add those up to get 8,120. And then just be careful with how you lay this out. So we know that we're doing bonds broken minus bonds formed equals energy released. So that looks like this. And then check the wording up here. We know that the energy released when forming new bonds is 1,640 kJ per mole, greater than the energy needed when breaking bonds. So that means those values there, the equivalent of equaling minus 1,640. So then sort this all out. So do 5780 minus 8120 to get minus 2340 plus 2x equals minus 1,640. To get 2x by itself, we add 2,340 to both sides. And then finally divide by 2 to find the value of one of those bonds. So your final answer is 350 kJ per mole.